So we've spent a bit of time looking at the least squares regression line, and I feel like we're getting quite good at graphing a least squares regression line and finding the equation. But we're going to sort of now look at another option for a regression line. So the least squares regression line is usually the best option, and it's pretty great because the calculator will do it all for us. But if we have outliers, we start to run into problems. So outliers will distort our least squares regression line. It'll actually pull the line that we have sort of above or below the data, or make it a misrepresentation, because the outlier will still have a big effect on skewing that data. So fortunately we've come up with a different way. It's a bit more complicated, takes a bit longer. The process is relatively straightforward though. And that's called the three median line. So you remember before when we used medians, medians were good because they didn't get affected by outliers. Well, that's the same sort of thing with a three median line. That's why we're using a three median line, not a least squares regression line. So it's another type of regression line. It's still putting a straight line on our data, on our scatter plot, but it's a different kind. It's a kind that is better because it doesn't get affected by outliers, but for us it's worse because it takes up more time to do. So that's the payoff. So that's all I've written here. It's another way of finding a regression line, and it's an alternative to the least squares regression line. So basically what we're going to do is the three median lines, we're going to put in three lines. We're going to split our data, and then we're going to put some x's at some particular points, and then we're going to join the lines basically. So I'll quickly read through the steps and then I'll show you some examples. We're going to split the data into three even groups, and so that might be, if there's 9 pieces of data, it might be 3, 3 and 3. But sometimes we might have 10 pieces of data. So we can't have 3, 3, 3 because that only makes 9. So we have to keep the outside 2 even according to our rule. So therefore we'd have 3 and then 4 in the middle and then 3 on the outside again. So we're saying if the groups can't be even, then the outside 2 must be equal. So you're either going to have 1 less or 1 more in the middle, or just the same. But either way, no matter what, the outside 2 have to have an even amount. And we'll see that in a minute. Step 2 is find the middle of each of those sections, this direction and this direction, the IV and the DV, and then we're going to put some x's where they are. Then we're going to join the 2 outside x's, and then we're going to move our line a third of the way towards that middle x. We'll see it in a minute, and I've just talked about that, about outliers. So let's do some examples together. Here's my first example that I'd love to do with you. So let's first of all count the pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In fact, I think this one might be easy to start with, just while we get a hang of it, because this only has 9 pieces of data. So 9, let's split that into 3 groups. So let's do these 3, and these 3. So I'm going to put some vertical lines to split it into 3 groups. So there you go, there's my first step. I've got 3 here, and 3 here. And I could split these two, I will need to eventually, split into 3 equal sized groups. And remember, if they can't be even, we'll put 1 more or 1 less in the middle, rather than the outsides being not even. So now that we've got our 3 lines, let's quickly split up these ones as well. Here we said there was 3, 6, 9, 12 pieces of data. So I'm going to split it into like 3 lots of 4 pieces of data, so that they're even. So there we go, there's 4 there, there's 4, and there's my last 4. So I'm not allowed to split it this way. I always have to split it horizontally. Let's do the same thing for example number 3. Let's check if you can still see it. You can. So same thing for example number 3. There's 3, 6, 9. There's 10 pieces of data. So I can't do 3 lots of 3. I'll have to do a 3 and a 4 and a 3 so that I get all pieces of data. So here's my 3, and then I'll do 1, 2, 3, 4. And you can see here I've got this conundrum. They're pretty much on top of each other. You can still do this. Technically, it doesn't matter which one I pick. It won't affect my median, which one I pick of them. So I'm just going to do that, and I'm just going to choose that one there. So my line's technically, yes, it's not a straight line, but I've just split it in across this way into 3 even groups. Same thing for the last one. 1, 2, 3, 4, 5, 6, 7, 8. So 8 is again not divisible by 3. I can't split into 3 even groups. So I'm trying to think in my head. 8, that's sort of like 3 groups of 3, but that's 9, that's too many. Why don't I go 3, 2, 3? That'll make 8. 3 and 3 is 6 plus 2 is 8. So 3, 2, and 3. So we can see in every single one of these we have the same amount on the outside, 4 and 4. And here we've got 3 and 3. Here we've got 3 and 3. And here we've got 3 and 3. So always the outside 2 have to be even. And in some of them the middle is the same as well. 3, 3, 3, 4, 4, 4. But here, 3, 4, 3, 3, 2, 3. So it doesn't always have to be 3 on the outside, like we've got 4 here. That's just an easy example for me to do. for us. So we've now done step 1, quick revision, split the data into 3 even groups. If groups cannot be even, then the outside 2 must be equal. Alright, step 2, we're going to find the middles of each of the sections according to the independent variable and the dependent variable. So what we're basically going to do is we're going to move across our data like this and find the medians of each of those sections. And then we're going to move across our data, find the medians this way. Let me show you what I mean. So if I'm looking at, let's start with example 2 again, these 3 pieces of data, just this section. If I move across, the median or the middle number is this number here. I'll show you what I mean. If I'm moving across, there's my first piece of data. And I'm moving across again, there's my second piece of data. Still moving across, there's my third piece of data there. So my middle piece, my number 2 piece of data is here. So I'm just going to put a dotted line to show me that, that's where I stopped, my middle piece of data. And then I'm going to do the same thing but going this way, going in my dependent variable. So I'm going along this axis here, my dependent axis. So here's my first piece, and I might just write a 1 there. Here's my second highest piece, and there's my top piece. So I'm moving from the bottom to the top. And before I was moving from left to right, I'm going across in the positive direction. So here's my bottom, here's my middle, and there was my top. So my middle one, we can do a dotted line across this way. So somewhere where my pen stops here. So now all of a sudden I've got these 2 crossing lines. This is where my first X is going to be. I'm going to put a big X there for us. That's my first cross. And then I'm going to do the same thing for the next 2. So I'm going to go, let's check my video, fantastic. I'm going to do the same thing with the next 2. So I'm moving across for this lot of data. So this is my most left one, this is the middle one, and this is the right one. So I'm going to be somewhere in line with this dotted line. I'm moving from the bottom to the top. This is my bottom one, this is my middle one, and this is my top one. So I'm moving this way. So my middle one was somewhere in line with this dot. And again, there's where my 2 lines cross. So I'll put a big X there. And sometimes you'll see, and we haven't seen it so far, sometimes you'll see the X's will actually be on a dot. Sometimes they'll be floating sort of in between dots. That's fine either way, but just, be aware that it might be on or not on a dot. Alright, let's go for number 3. So I'm moving again across this way first. And here's our middle piece of data. So 1, 2, 3. 1, 2, 3. So somewhere in line with my middle piece of data. And from the bottom to the top, because we're finding medians, that's why we're going into the middle of the data, and we're not averaging them. So from the bottom to the top, 1, 2, 3. I'm moving upwards this way. There's the first one, the second one, the third one. So somewhere in line with this second highest piece of data. And there we go. And there's my third line. So step 3 says to us, join the outside X's together with a line. So we're just going to join these 2 X's together with a line. I'm going to grab another colour. And I didn't bring a ruler, you'll have to forgive me. I'm going to use my iPad cover. So we're almost there. I've joined my outside 2 X's with a line, and it's really lucky in this case that my middle X is already on the line anyway, so I don't have to move the line 1/3 of the way towards the middle X. But if the X was down here, I'd be pushing this whole line towards that one, but 1/3 of the distance. We'll see that in some other ones, and become a bit more clear how that works. So that's basically how I do my 3 median line. I'll just quickly do these ones with us as well. In fact, I might stop the video here. If you feel like that's enough examples for you to start trying, that's fine. But if so, if you want to do 3 more examples with me, you can watch the next 3 questions.